Okay, so we are talking about analyzing functions using symmetry and absolute value. All right, so we have three different types of functions. We have evens, odds, or neither. So the even, we can look at them algebraically, which I'm going to show you in a minute, or graphically, which is much easier. So graphically, an even function is symmetric with respect to the y-axis. Okay? So for example, on my cute little graph here, if I have a dot here, let's just say this cute little dot is at -3, 2, then symmetric or an even graph would have a dot at +3, 2. Okay, they're basically a reflection across the y-axis. It's a terrible line, whatever. Okay. And then when you plug in -x, then you get the exact function. I don't love that. Anyways, okay, and then an odd one algebraically is when you have the opposite and you have plugged in the -x, then you get the exact answer. Anyways, I don't like how it's written. Okay, so the graph has 180 degrees rotational symmetry. So for example, if I have a dot at 4, 1 here, to have an odd function, this guy would have to rotate 180 degrees, so he would be at -4, -1. And then we would know that he is odd based on the picture, because if I rotated my picture upside down, he would have the same shape. So for example, with graphs, this guy, if I cut my line here, then the left side is the same as the right side, which means that this is an even function. Because if I picked like 2, 2 on this side, then on this side I also have -2, 2. Okay? This guy is an odd function, because if I picked a point like 2, 1, then over here, this guy, if I rotated him around, -2, -1 is still the same. So basically, if I turn my picture all the way around like this, I have the original picture that I had before. So that's odd. Even just means like and it has to be about the origin too. Even means that I just cut it here and then I could flip it in half and the two halves would match. So on C, this guy, if I cut here, then I'm not going to get the same picture on each side. And if I rotate, right now I have a U, but when I rotate like this, I do not have a U. So this isn't even and it's not odd, which means that this is a neither function. So now I'm going to show you how to do it algebraically. So the first thing we want to do is we want to determine whether this guy is even. So to determine if it's even, we're going to take our function and we're going to change our input to a negative. Okay, so now we have x, or 8 -x cubed. Okay, what this really means is that we have 8, and then we have to distribute this 3, the cubed, to the x and the -1. So we have -1 cubed and x cubed. Well, -1 cubed is going to be -1. So this really breaks down to 8 times -1 times x cubed, which is the same thing as -8x cubed. Okay, so now notice, this guy is different than the original guy. So he is not even. So now what we're going to do is we're just going to make him opposite. So we're going to take the whole function, -f of x, and make it opposite. So the function, make it opposite. So that means that I am going to distribute a negative to the things on the inside. Well, 8x cubed is one term, so when I distribute my negative, it just goes to the 8. So this would end up being -8x cubed. Now, if I'm looking at my three answers, I have my original function, I have my first guy, which didn't match, so it's not even, and then I have my third guy. So since these two match, this is in fact an odd function. If none of them match, then it's neither. Okay, so let's do it again. So what you're going to do is you're going to take your function and you're going to input a -x to your function. That means that everything stays the same, but your x becomes negative. Okay, so again, this means I really have negative 1 squared and x squared. So that gives me negative 2. Negative 1 squared is 1, so it's really not going to change anything, and then I have x squared. Notice here, this answer is the same as the first answer. That means this function is even. Okay, for C, we're going to do the same steps. So the first thing, and you can stop there, you don't have to do anymore. The first thing we're going to do is we're going to take our function and we're going to make our x negative. That gives me negative x squared and 2 negative x, like that. Well, again, this means negative 1 squared, and that's the same thing as positive 1. And so we just have our x squared left. Positive 2 times negative x is negative 2x. Notice that this function and this function do not match, so it is not even. So now we're going to test if it's odd. To test if it's odd, we're going to make the entire function negative, or opposite. So we have negative, and then it's x squared and 2x. So I'm going to distribute this negative to the x squared and the 2x. That gives me negative x squared minus 2x. Okay, so now I look at this guy. Now this guy is not the same as this guy. So none of the 3 of my answers match, which means that this is a neither. Okay, so let's keep going. Let's do some more. Okay, down here, so we're going to determine if these guys are even, odd, or neither. So the first thing we're going to do is we're going to make our x, our function, in our function negative. So the absolute value of negative x and 5. Well, if I take the absolute value of negative 1, then that's going to be 1. And if so, it's going to be a positive 1 and my 5. Okay, now this matches my original function, which means it's even. Oh no, hold on, sliding. Goodness. Okay, then this guy here, we're going to do the same thing. So we're going to take our function and make our x negative, which means we have the absolute value of 2 times negative x minus 1. Okay, well, 2 times negative x is negative 2x minus 1. Well, this guy does not match this guy. So now we're going to make the entire function opposite. So we have negative 2x minus 1, like that. Okay, well, those don't match either. So this one isn't either, because we can't distribute this negative in its an absolute value. Okay. So what we're going to do is we're going to take these two functions and we're going to take the absolute value of them. So remember, the absolute value means that we can't have negatives. So what we're going to do is we're going to take this part that's negative and we're going to put it in the positive. So the absolute value refers to the distance from 0, and the distance is always positive. So no matter what x we put, we should always get a positive y. Okay, so that's what we're going to change. That means that this whole thing is now flipped up here and looks like this guy. And again, this whole thing is flipped up here to look like this guy down here. So let's do this one first. The domain. Well, our domain is going to go to the left and right forever. So negative infinity to infinity. Our range is going to go down to 0 and then up to infinity. The intercepts. So we have our x-intercepts. So where we cross the x-axis will be at negative 2, 0. And we have one at 2, 0. Our y-intercepts touch here at 0, 4. Okay, we're increasing. So this is a decrease, here's an increase. Okay, so we're increasing from negative 2 all the way up to 0. Because remember, it's just looking at the x values. So negative 2 to 4, but that really is just a movement to describe it from here. Now we start to decrease, and again, we go back up from positive 2 to infinity. We are decreasing here down, so that would be negative infinity to negative 2. And also, we are decreasing from 0 to 2. Okay, positive. We are positive when we are above the x-axis. Okay, so above the x-axis, and remember we don't want to include things that touch the x-axis because 0 is not positive or negative. So positive from negative infinity to negative 2, and then we're also positive from negative 2 to 2, and we're also positive from 2 to positive infinity. We are negative nowhere. Our maximum, so this guy is a relative maximum. He's not an absolute because the graph continues on above him, so he's not a true maximum, but he's a relative maximum. So we're just going to write him down, 0, 4. We don't have a minimum. Oh wait, yes we do. Silly. This guy's a minimum, negative 2, 0, and this guy's a minimum, 2, 0. Forget about that sometimes. Okay, symmetry. Well, it looks like if I cut right here, I could fold them on top of each other. So that would mean that this guy is even. And the end behavior. The limit as x approaches negative infinity for the function is up, so that's positive infinity. And then on this side, the limit as x approaches positive infinity for the function is up, so that's also positive infinity. So many things to describe the graph. Okay, let's do one more. So the domain is going to go left and right forever, so that would be negative infinity to infinity. The range is going to go down to 1 and then up forever, because that guy. The intercepts. So we have our x-intercept at 1, 0, and our y-intercept here at 0, 2. We are increasing, this is a decrease. Our increase actually starts at 1 and goes to positive infinity up here. And our decrease comes this way, negative infinity to 1. Okay, remember these are all in terms of the x-axis. We're positive from negative infinity to 1 and from 1 to positive infinity. We just can't include that 1 because it's at 0. We're negative nowhere. We don't have a maximum. Our minimum is here at 1, 0. And we don't have symmetry. It can't turn around. I can't cut it here. It doesn't have symmetry. The end behavior. The limit as x approaches negative infinity for the function. So this guy is forever going to get closer to 3. So that's the limit. On the left-hand side and the right-hand side, the limit as x approaches positive infinity for the function, since we're going up, that is a positive infinity. All right, so that's how you do all of these things. If you have any questions, let me know. Have a great day, guys. Bye.